Okay, so finding removable discontinuities. Okay, so find the vertical asymptote, oops, the vertical asymptote and the removable discontinuities. There could be more than one, but we'll see. Okay, so let me scroll this up. And we're going to talk about the graph. It doesn't ask us to graph it, but I think we should talk about it. The more of these graphs you see, the more familiar you'll get with them. Okay, so our original function, we have x minus 2 in the numerator. That doesn't factor. And then we can factor the denominator, x plus 2 and x minus 2, because it's the difference of squares. So we know in our domain that x cannot be negative 2 and x cannot be 2. That much we know, okay? So keep that in mind as we go on. Okay, now the function simplifies because those cancel, and so we get k of x equals 1 over x plus 2. That means this is a reciprocal function, and it's shifting 2 shifts, it's a horizontal shift, so 2 to the left. Okay, and I told you we were going to talk about the graph. Okay, where does the vertical asymptote occur? In this case, we're only going to have one, and it's based on that denominator right there. So x cannot be, or x equals negative 2. That is the vertical asymptote. Okay, that's the part that we can't have x be negative 2 in the domain, and that's why that vertical asymptote exists. Okay, let me draw then a piece of graph paper here. So at negative 2, I'm getting this vertical, we'll do it in green, vertical asymptote right there. Okay? Now, what about the removable discontinuity? Well, so the removable discontinuity, I'm abbreviating, it occurs at x equaling 2. Okay, so that's where there's going to be this hole in the graph. So let me count over to 2 here. There's going to be a hole right here. Okay, now you might say, well, how do I know where that hole is going to be? You would get a table of values if you wanted to get accurate points, or you could think about the transformation of the graph. We know it's a reciprocal function, so we know it's going to be coming up like this, and then it's going to be going toward the x-axis, okay? The x-axis, by the way, is the horizontal asymptote here. I didn't draw that in. And then the other part of the graph is just going to be over here. So that's kind of what it looks like. We get a hole in the graph at 2, and we get a vertical asymptote at negative 2. And then there's a horizontal asymptote on the x-axis for this problem. Okay, so that's how you do that.